This is James at JTech. Then I'm going to go over testing just a simple lighting circuit. The circuit in question being just that light for the fuse panel. Just going to check the voltage on it, check for any voltage drop, or to see if we have any problems that needs to be addressed. Try to focus this thing. Okay. So this works for any electronic circuit. It's just important to remember that while checking voltage, the circuit needs to be live. It has to have power going to it, otherwise you're just going to get a zero reading, or whatever millivolt reading the meter is going to read. Also, you want to keep in mind not to probe too far or spread out the connectors. So let's see what we got here. Should read as close to battery voltage as we can. It's kind of hard to see it. Looks like 13.28 I saw. I'll go in and revise it if I need to. It's just kind of hard to see it. Next, you just want to compare that with battery voltage. Just see, and you could subtract the difference and see what the drop is in that circuit. If it's excessive, then you have corrosion, bad connection, loose connection, bad wire, something like that. But let me just get a reading on battery voltage real quick and just compare the two. So battery voltage 13.6. If I remember right, the voltage at the light was 13.4. Again, I'll check that and see if it's off. I'll just annotate it. But you're looking for the difference in those two measurements of the battery and at the end of the circuit. Now say this measurement was, I'll say it was 12 volts. You could go through the entire circuit or through all the connections and see where that voltage is being consumed. You want most of it being consumed at the lights. That's, your main load. It gets harder for, more complex circuits. Say you're doing like a turn signal or brake light, you got a few more connectors you need to check, but same principle. You just check all the connectors and compare the drop with battery voltage. Few things to consider: if you have any switches, say like an electric fan motor, you need to make sure that electric fan motor is engaged. Otherwise, that motor is not going to receive any power, and you're just going to read zero voltage. You can also do continuity checks. For continuity checks, you just got to make sure the circuit's not live, because the voltmeter acts as your battery at that point. This applies something like 200 millivolts to the circuit. It's not a great test for high amperage circuits because of the low amount of voltage going through the wire from the meter, but it's a quick test just to see where your highest points of resistance are. The things that'll affect that: loose connections, corrosion. Just gotta remember, I think it's malt, material. I'll annotate that, but that's a good, I can't remember off the top of my head, but that's a good acronym to remember: malt, M-A-L-T. I'll look it up and post an annotation saying what it is. I just can't remember off the top of my head. I think that's just about everything. It's just the basic principles here. Next video I'm going to be testing in an electronic circuit, so I'm going to try to tackle something with a switch so you can kind of see like the voltage differences as you actuate the switch. Alright, thank you for watching.